Okay, so let's look at this problem. You operate LSC Test Prep, which owns a linguistic and mathematics tutoring company. You cater to high school students seeking both linguistic and math tutoring, and your tickets are good for either a linguistic or math tutoring session. Your marginal cost, which comes from the fact that you must pay the LSC student who is good at both linguistics and math, is £13. Let me just get this. Your sessions are equally split between math and linguistics. As a pricing experiment, you raise the price to 35, your quantity falls to 42. Is your price 30 right in the sense of maximizing profits? Let's think about this question. Okay, so here's one way that you could have solved this question really simply. Let's divide this into a before and after. So this would be your before, this would be your after. What do you know about your marginal cost? Your marginal cost is 13. What's the marginal cost here? Well, that hasn't changed because that experiment did not affect your marginal cost. Okay, you still have to pay people the same amount. And then let's talk about quantity for maths. What was the quantity for maths? How many units, how many hours of tuition were you selling? 30, right? Because you were teaching about 60 sessions per day and your sessions were equally split between math and linguistics. So quantity of linguistic was also 30. And what was the price for math sessions? 30. And you were charging an homogeneous price of 30. For linguistic as well, was also 30. Now what happens? Quantity of math, or your overall quantity actually, we don't actually know the quantity of math, but we know that Q total prime is now equal to 42. Okay? Is your price of 30 right in the sense of maximizing profits? Well, let's think about this. What is the only thing that you've been given is that now the price here is prime is 35 and you're charging the same price for both math and linguistics, okay? Same thing. What's one sort of like almost like a dumb way to solve this question? It's not really a dumb way, but it's really an easy way. Yeah.
Just multiply the price and quantity of before and after and compare them.
If you did just that, you'd be comparing revenues, okay?
Oh, yeah.
But what you do want to compare is profits. So really what you had here, you're selling, what would be the profits here? Profits before would simply be 60 times 30 minus 13. What about here? Profit after? 42 times 35 minus 13.
But wouldn't it be minus 13 per quantity?
Yeah, it would be. So for every unit, this 13 would be per quantity. That's why I have the 60 in front of here. Of course, I could have broken this down into 60 times 30 minus 13 times 60. Right? So this would have been the revenue. This would have been the total cost. What sort of approach am I using here? I'm using the approach of writing profitability as quantity times price minus marginal cost. You could write it that way as well. If you don't have any fixed cost, you can write the profits that way too. Okay? Now, let's get to what Louisa asked just a second ago. Imagine that I'm drawing a demand. So I can do this very easily this way, okay? Like I can figure out what profits are in both settings here, right? So what's the, let's pull out a calculator. 60 times 20, 17. 60 times 17 is equal to 1024. 1020. 42 times 22, is that right? Is equal to 924. Okay? So, is your pricing right in the sense of maximizing profits? Well, we kind of know that this experiment failed a little bit because our profits went down. Okay? But we want to do more than just saying this experiment failed. Right? You want to do a little bit more because now you have some information about the demand. Okay? So it was what Luisa kind of hinted towards, that if I have these 2 points, I can actually draw the demand. But if I know the demand and if I know the marginal cost, I can figure out precisely what the optimal price should be. Okay, using either the inverse elasticity pricing rule or using the rule that I showed you about being half of the point between marginal cost and the demand. So let's try and do that. So what were you given? You were given quantity, price. This is quantity of math plus quantity of linguistic. You knew that you had a point that was 30-30. So I can draw it here. 30-30. And you know that you got a second point, which was 42-35. Sorry, 60. $60-30, and you have 35-42. Okay, that's what you have. So intuitively, if you wanted to, you could have drawn this completely to scale. And after you've drawn this to scale, so for example, you could have added a layer. I could have added a layer here and really done my best to have drawn this to scale. But you can get a sense that if I have those 2 points, I should be able to draw a line, right? Now the question is, how do I do that mathematically? How can I go about drawing that line mathematically? How can I figure that out? How can I figure out how that line will look like mathematically? Yeah?
You need to find the y-intercept.
You need to find the y-intercept, you need to find the x-intercept, you need to find the slope, right? So if you think about the line is P is equal to A minus B times Q, right? That's what you need to find. Can you find the slope, the B? And you know it's negatively sloped, right? Can you find the slope? How would you go about finding the slope? Thanks.
Well, do the rise over run.
You do the rise over run. What is, when I moved from the original point A to this next point B, what was the rise or the change in price or the delta P? It was just 5. What was this run here? It was 18 or minus 18 if you like, right? I've already taken care of the minus here because I've already put a minus in front here. So I'm only going to look at absolute values just to make my life a little bit easier. So then I already know that P is equal to A minus 5 over 18Q. I already figured out the slope by just having those 2 points, okay? Now that I have those 2 points, how can I figure out the A?
We already know what P and Q are, so we just plug in the numbers.
Exactly. We already know for one of these things what P and Q are, right? So for example, if I know that P is equal to 30 and Q is equal to 60, must satisfy this equation, I could just plug them in. 30 is equal to A minus 5 over 18 times 60. 6 times 3 is 18. So I can divide this by 6. This becomes a 3. This becomes a 10. So then I have 30 is equal to A minus 50 over 3. A will equal to 30 plus 50 over 3. Okay. What is 50 divided by 3? What is 50 divided by 3? Well, you can put a calculator, okay? If you don't want to like struggle too much with it, you can do a calculator, okay? So this is 16.67 approximately, okay? That's what that number is kind of telling you. So far so good, yeah? So the A will be approximately 46.67. And I'm done. I can now visualize this. So I'm not going to draw this to scale, but I'm still going to be able to visualize this. So I can say, okay, my demand will start at 46.67. It would be downward sloping. It will have a slope of 5/18, so like a third. So if it's a third, if I want to draw it to scale, this base thing, right, should be roughly three times this, right? If I was drawing it to scale, roughly. Okay, I didn't have to draw it to scale, and you'll realize that I actually don't need to draw it to scale. Okay, I really don't need to draw it to scale, and I have some marginal cost here, and I'm not drawing this to scale, by the way. Marginal cost is equal to 13. So from my pre-sessional courses, what do you know? What is the monopoly price? What's the monopoly price on this? It's somewhere in the middle. Right? It's the average point of this bit here and this bit here. Okay? So this is about 47. 47 plus 13 is about 60. 60 divided by 2 is about 30. So your price was about right. Right? Your price was about right. So selling 30 and 60 was about the right price. Okay? How could you have done this differently? How could you have seen this differently? Let's say you didn't like this shortcut that I used here, right? Remember what I used here? If you have A and you have MC here, P star will equal to A plus MC divided by 2. That's what I used here. But let's say you didn't like that. And you said, but Ravi, this is not how we did it in the lecture. We did it with the inverse elasticity pricing rule. And you say, okay, let's do the inverse elasticity pricing rule. P minus MC over P must equal to 1 over the absolute value of E at this particular point A. Because remember, elasticity is a local property, okay? Well, let's think about it. What is then EA? Well, EA we said is partial of Q with respect to P times P over Q. And if I'm doing it at A, it must be at A, and this derivative must be evaluated at A. Well, I know this is nothing but 1 over the slope. Okay, so I know this thing here will simply be 18 over 5. 18 over 5. What is this? Well, I know this is 30, and I know this is 60. So this is 18 over 5 times 1 over 2. This is about 9 over 5. If I flip this, note that I'm getting rid of the negative, okay? I should actually put a negative here because it will be the negative of the slope. So if I put it here, I should have 5 over 9. Should be this side here. Okay, let's do this other side here. 30 minus 13 over 30. Okay. So that would be what? 17 divided by 30. Okay, let's do it. 5 divided by 9 is equal to 0.05, 0.55. 17 divided by 30 is about the same, right? So the price is roughly right. And so we're roughly there in terms of the pricing rules. And this is how I do this part A in full, and I'm kind of showing you with different angles. Yeah.
Which is the preferred option?
Any, whichever one you like the most, right? But keep in mind that in the exam you need to motivate this bit here, right? Like you don't want to just, if it's a multiple choice question, then it doesn't matter because your goal is to find the right answer. But if it's an extension question, you want to show the examiner that you understand where that formula came from. And that formula came from the optimization problem. Yeah.
I'd be happy if I just did like the profit function and maximize the profit
Yeah.
function.
Yeah. You could have just realized and got the demand function and said, I'm going to just maximize it and figure out what the optimal price is, right? That would have been another approach, would have been a better approach, because this formula here came from the general version of that approach. So trying to maximize profit, if you go back to the pre-sessional, to the video that we did on maximizing profit, the monopoly problem, I got to this formula by exactly maximizing profits. I'll stop here. I'll give you a couple of minutes to discuss it. I'll take more questions on this.